Gold is not everything, but everything needs gold. This old proverb perfectly captures the essence and value of gold. From jewelry to coins to computer chips, gold is essentially everywhere. But did you know that all of it originated in outer space, with its creation dating back billions of years? In fact, the answer to the origin of gold lies in the death of stars, the traces of which begin at the Big Bang. The Big Bang, the explosion that first gave birth to the simplest of all elements. During the initial stage, elements such as hydrogen and helium formed. All these gases combined over hundreds of millions of years to form the first stars. This began the process of creating heavier elements. As stars shined and released energy, nuclear fusion transformed hydrogen into heavier elements. First helium, then carbon, then oxygen, and finally iron. But for stars, the process for the creation of even heavier elements within stops here. The creation of elements continues today, but forming heavier elements like gold requires an immense amount of energy. So much that it can only occur during the death of one or more stars. Let me explain. Nucleosynthesis is the name of the process that creates newer and heavier elements from lighter ones. The most common of all is the process of making hydrogen into helium, the same process that happens in our sun. Since the Big Bang, most of the nucleosynthesis happens inside a star or during its death in a supernova. Supernova refers to the explosion of a dying star. Stars are mostly composed of hydrogen. With passage of time, a star converts this hydrogen into helium. This helium converts into heavier elements like carbon and oxygen. Eventually, there comes a point where the star runs out of its fuel and explodes in a supernova. Initially, scientists thought that supernova was responsible for much of the creation of gold in our universe, but that may not be the case. Research shows that heavier elements form during an even more extreme event known as kilonova. This rare cosmic event happens when two neutron stars in a binary system spiral and collide into each other, creating conditions of extreme density and neutron flux. In 2017, for the first and only time, a kilonova event was observed to create gold. The collision created at least 10 Earth-size worth of gold. Only during such extreme conditions can an element like gold be made. The process by which it happens up close is known as our process. In the explosion or collision of dying stars, the conditions become so extreme that they rip apart the neutrons of atoms. In a flash, the environment becomes cluttered with free-floating atoms and neutrons. In nature, new elements are created by adding protons and neutrons. For instance, an atom of hydrogen is made up of one proton and one electron. During this environment of high influx of neutrons, the free atoms start to grab the floating neutrons quickly. The atom grows in size and becomes unstable because of many neutrons. To balance the nature of the universe, the captured neutrons instantly undergo what is known as beta decay, which makes the atom change some of the captured neutrons into proton rapidly. This makes lighter elements into heavier ones. As the process continues, more and more neutrons are captured by atomic nuclei and more heavier elements are created. Eventually, the universe ends up with elements like gold and uranium. Stars can spend millions of years making lighter elements, whereas when a star dies in a collision, in mere seconds more rare and expensive elements are created. But how did all this gold ended up here on Earth? It is hypothesized that about 4 billion years ago, when our planet was in its early molten form, a lot of asteroids composed of heavier elements crashed on our planet, and much of it sank to the core. This is the reason why we find gold underneath the Earth's surface. As of 2023, more than 200,000 tons of gold have been mined. While it sounds like a lot, If you put together every piece of gold that we currently have into a cube, it would only measure about 22 meters on each side, making it a scarce and expensive element. Because of this reason, many attempts have been made throughout history to artificially make gold. As recently as 1924 and 1941, gold was apparently created accidentally, but it was deemed an experimental error since it could not be replicated. A similar attempt made in 1980 was successful, but it was too expensive to continue as well. With an atomic number of 79, meaning there are 79 protons in gold, theoretically gold can be created by adding or removing certain number of protons from other elements like copper or mercury, respectively. In fact, today it can be manufactured in nuclear reactor, but it is highly impractical and would cost far more than the value of gold itself to produce it. Unlike silver, which turns black, copper that goes green, or iron that rusts, gold never changes. It seems to be immortal. A gift from the gods. That's what the Egyptians believed thousands of years ago. The importance of gold is still as relevant. In fact, we have even found new use cases for it in the form of computer chips, enabling the very device you are using right now to watch this video. So the next time you see gold, don't just think of it as a shiny piece of metal. It is quite literally a fragment of star that you are seeing. If you enjoyed and learned something new, please subscribe, hit the like button and share it with your friends. It helps a lot in continuing to make more videos like this.